Jaime Garcia.
Ooh, yeah. Be the love generation.
Hello. Primero quiero disculparme por mi mal portuñol y voy a expresarme en inglés, pero con toda confianza pueden interrumpirme. Thanks for the opportunity, thanks for the invitation. My name is Jaime Garcia. In this opportunity, I want to share applications of 3D printing using a large-scale printer for foundries to use in models and patterns for fast production. It's an application that is growing using the additive manufacturing as a part of the innovation to respond faster, because it has been a bottleneck in the production for all around the world, because the companies before the pandemic, most of the patterns were produced in China, and now that becomes a problem that everybody wants to control their own destiny. What I want to share today is a little introduction of my company. What are the challenges that the industry, foundry industry is facing today? What are the benefits using manufacturing, additive manufacturing? Some examples of customers that are using this technology, and some conclusion at the end of the presentation. Starting 3D Systems or 3D system was founded in 1986, and the founder, Chuck Hall, is the father of the 3D printing. He patented the stereolithography, and basically he launched all the additive manufacturing industry thanks to his invention. My company design and produce 3D printers and a lot of specialty materials for multiple applications. We have presence in more than 35 countries. We have more than, well, now it's like 2,000 employees around the world. And one of the approach that we as a company we have is instead of selling printers, we try to offer solutions. The solutions comes from the application, the customer needs, and see if there is any printer and material that can solve that problem. Based on that, we are organized in industrial segments and healthcare segments to offer solutions, and people specialize in those industries that can understand and speak with the customer exactly what they need and save time to try to solve the problem, instead just send a product and the customer figure out how to use it. That is not what we do. Again, as I mentioned, we have presence in more than 65 countries with a lot of partners, like Rescam is one of our stronger partners here in Brazil. And we have customer innovation centers in US and Germany. Basically, the mission of those centers is to understand the customer needs, establish how to produce the parts in the 3D printing, validate the parts, and once the customer is satisfied, the technology is transferred to their own site with its right printer, with the right training and everything. And then basically the Customer Innovation Center, the mission is to be sure the solution is going to be according the customer needs. In terms of printers, we have 9 different technologies, from material extrusion for to photo curing material, selective laser, and even we have metallic printers with multiple materials. For example, we have almost 30 metals developed for our printers and more than 100 plastic materials for the all other printers. Now, talking about the foundries, what are the challenges the foundries are facing today? First is reduce lead time. This is the major challenge, how to reduce lead time to create a model or a pattern to produce parts, and that production of the model drives the second challenge. The expertise to create models is an art that is being lost. People in the past has a lot of experience doing models, and those persons are retiring and the new generation is not picking up. And now the technology is trying to compensate that expertise that has been more scarce, more difficult to find. And the other is how to reduce the cost of the mold. Producing the mold and the patterns is also expensive and sometimes require big production lot that can compensate or justify the investment. And in most cases, the cost of the pattern is the difference between go ahead or stop the project. What are the solutions that manufacturing additive manufacturing is offering? Basically, printing with 3D, we can have basically any geometry that we want that can simulate what a model or a modelist used to do by hand, working with wood and other materials, printing directly the mold. The limitation that has been in the past is the commercial printers were small in size, and industries like auto industry or energy, they have been working with parts very, very big, and the printers were not big enough. And then with the solution that we have in our portfolio is a printer that can have up to 1.2 meter in length and 1.8 meter in height, that is big enough for sufficient parts, and then create molds and patterns directly from the CAD model. That is the major advantage. The second advantage is the material. Once we talk a mold, usually the mold, in this case the pattern of the model, requires materials usually like aluminum that can support abrasion of the sand during production and have a good thermal stability to avoid distortions because different temperatures during the year operation. The materials has been growing in capabilities and technology, and now one of the advantages is that the printers now can use the directly raw material that is used in injection molding industry, that is in the pellet form, and then the pellet is the most cost-effective material with the same properties that we can get from injection molding. That is one of the major advantages. And with composite materials, with carbon fiber or glass fill, those kind of additives or composites makes a plastic equally in terms of abrasion resistance than some metals. Even in some cases superior than the metal. Metal tends to wear faster for some reason when they are exposed to sand. And this has been a solution that has been successful with a lot of foundries. This material, that is the carbon fiber ABS, is the material that has been proven in the last 3 years after testing different materials through time. And this is a good solution that has been lasting more than 3,000 shots and still working. One example, for example, is once the pattern is printed, is very good for the process of green sand or no-bake sand. However, has been tested also in a different kind of technologies like investment casting or loss foam. Those are the other technologies that has been tested, but the major advantage has been in the green sand and the no-bake process. When we compare how a traditional mold is produced, usually, depending on the volume, always start with a master pattern. The master pattern is done with wood. And the wood needs to be with a very special material, like mahogany wood, to have good durability. And that master, if the volume is going to be big, that master produce the aluminum pattern for production, and the wood remains as the master to produce more in the future. Usually this process starts in the model in 3D and then generate the CNC programming and multiple setups, and all this time, usually in average, parts takes between 6 weeks to 2 months. When additive manufacturing is coming, the code generation is automatically. There is no manual programming for CNC. That saves time. Printing the parts can be done in the same day. That is another advantage. The post-processing, like cover and painting the pattern, is still the same, but the major advantages is in the intermediate steps. And when we compare, basically, we are looking for 4 to 5 weeks reduction in time, thanks to the advantages in 3D printing. The other concern that customers had, and we launched this study, is the durability of the pattern during the usage. And one part, for example, was 3D scan and documented just as printed. And then after 16,000 cycles using the process for sand casting, was re-scanned. Well, actually was a scan every like 2,500 or 3,000, and was monitoring. And even at 16,000 cycles, the part is still under the parameters of expected tolerances, showing that the wear has been very low for the parts using the carbon fiber with ABS with carbon fiber. Here, for example, in this table is the comparison of benefits when we see, for example, the 3D printing. The material is available almost immediately. Those are material in stock that can be ordered and received in 1 or 2 days, while the CNC process requires a special wood with high grade quality that not always is available. Other of the limitations is even if the wood is available, needs to be under certain parameters for the application. For example, having the same wood for furniture is not the same for a production in foundry, and not necessarily always meet, and that makes a little bit more difficult to use it. The other is for 3D printing, based on the big size printers, can be simplify the assembly or the process to create the whole boxes for the sand casting. The cost of the material per kilograms or per volume, unit of volume, is also much lower. We are talking about like a $300 for a box, while the same equivalent is almost $500. with good in the same volume. The lead time is basically the major advantage because can be printed in few hours instead of waiting lead time of the good. The other opportunity with the software is that the software that has been launched for years in the finite element analysis, there are ways to optimize foundries to reduce weight without going to a very complex geometries like directly 3D printing. Usually we have been familiar with the topology optimization more for 3D printing directly in metal, minimizing the weight and minimizing the mass of the part. But for foundry, there are process limitations. We still need to have draft angles. We still need to have consideration of the process, but there are options to make also further optimizations with the newer software. There is another option to reduce mass if necessary. Case study. This company, PSSI, is part of a foundry in Mexico from Fundidora Morelia. And they started the first project with a housing, water pump housing. And this basically was their first project. And in this one, they generated all the parts, the internal cores, also the external parts, and they applied that final painting to improve the surface quality. And the reduction in time was 50% to prepare this compared with the good process. In the similar case, this other study was for the impeller. The impeller was printed in two halves because it was too big for the printer, but the two halves were basically assembled afterwards, and one is assembled is like a single piece. And then this one also is a piece that weighed 55 kilograms, but the cost was just $300. And the reduction in time and labor also was a big benefit for them. Another examples that they have been sharing is very big parts, and in this case, for example, was printed vertically because the size of the printer. But anyway, at the end, you can see in this assembly, they put together single pieces, but the solution was also reduction in time and cost, and the labor was much less than traditionally working with wood. For cost estimation, we created an Excel file that can be a good simulator to estimate the cost of printing a part. And here, this example of a pump, we start with the all investments that is in the top area, basically all the investment required for the printer and accessories, and all the service package, and the cost of energy, and based on 10 years of usage is the estimated cost per hour running the printer is less than $4.50 per hour. And then we calculate the printing time, in this case 15 hours, plus the 15 hours times the 4.39, that's $70. And we put the volume of the part, and this gives us the cost of the part with the all investment, energy, and everything, while the material is $80 for a part that weighed for 6.3 kilograms. Then this is a very comprehensive and complete cost estimation that can give an idea how much cost to operate the printer and how much costs the material. We are talking a material of $18 per kilograms. This is priced in USA. in United States, but because the printer is open source, the material, if it's available in the country, can change for the local source with no problem, and even could be even more cost effective here than in US. And when we compare the same model in the two process, we are talking about $179 versus $420 using good material. Another example here, similar part with a big cost reductions. Another example. One more example. And this is a test that is in process right now. There are foundry process that is used the lost foam. The lost foam is used for more complex parts like engine blocks, and basically we are printing the whole model to apply the polyurethane in a foam way, and then this foam is assembled, and this is in process but looks promising to have also the solution for another foundry process. Another process that is also special is the vacuum process, where the mold is covered with a film to facilitate the disassembly and also to have better surface quality. This is basically just a simulation of how the vacuum process is working, and the 3D printing mold has been proving also a lot of advantage, because 3D printing has the availability to use porous material, and with the porosity, the vacuum of the film is more effective. And then the molds are also more simpler to design, because there is no need for vacuum channels or other assistance for the vacuum passages. And wax molds also has been testing. One of the material that has been tested is made by this company, TC Poly. That is a plastic that has thermal conductivity capacity. There is also another project in process to have options to create wax molds for investment casting. To show what are the printers that we have been using for this process, this is the family. The family is the Extrusion Titan, and we have 3 models. And the model, the small one, was just launched at mid of this year, but we have also the big one that is 1.2 meters that has capabilities even for machining tool option if necessary. But those are the printers that has the volume that has been producing all these parts, and the raw material using pellets has been the big success. Another advantage that we have, the build chamber can be preheat to avoid distortion during printing, and that has been a very success solution to avoid printing problems that other printers or competitors have been experiencing, because all the print inside of the printer is warm to avoid distortions. And here, for example, just part of the kind of the marketing campaign, just to show the configurations of the 4 different printers. There are several accessories that can be attached, but basically the bigger size printers are prepared to have everything. But even the small one, the small has a standard, the pellet extruder, to have the best cost material. As I mentioned at the beginning, all the pellets that are the raw material for injection molding opens an opportunity for multiple applications, not only in foundries, where, for example, high-grade materials like ULTEM, polycarbon, PEC is available to print. The printer can work with those big great materials, but also there is available for the common and commercial materials for rapid prototyping or big easy testing, and also innovating with a solution, for example, transition from a hard material to a soft material in the same part. That is another to consolidate parts, eliminate assemblies. Other solutions in the 3D printing is if the application requires supports, there is a support material made by these companies, Aquasys, that is water soluble, and this means the printing can be put in hot water, and the support is made of corn and dissolved and is completely biodegradable. That doesn't contaminate, and then is a big advantage having a support that can be dissolved and not a special dispose process. The capacity of the machining capabilities give us the advantage that, for example, we can use very big speed with a rough surface and finish the surface with the machining. But the material here is the most advantage. This is just playing what are the best time to print parts. Before jumping to the conclusions, I just want to mention another advantage using the pellets material for 3D printing. This material is thermoforming. What customers that has been using this technology, they have been able to reuse and recycle the material for future uses. And then one of the big problems also for foundries is when they have the tool and they finish the order for the customer, they store the tool for months and even years until the potential new order, and they have the storage area bigger than the production area. They have patterns and tools for years, and they don't want to dispose or destroy them because the concern that a new order from customer could show up soon. With the 3D printing technology, they are starting to create digital inventory. With the digital inventory, you print the pattern, deliver the batch of the casting parts, and then you destroy and recycle the material. And if a new order comes months later, just reprint the mold. And then that saves space, saves time, and also material can be reused, and is one of the major advantages. The material is repelletized again to be consumed in the same printer, and then that has been also a big advantage from a sustainability approach. And just to finish here my speech, the conclusion is we have demonstrated with multiple customers in US, in Mexico, and also starting here in Brazil, using this material and this technology, save time, save cost, and open the possibility for a lot of innovation using 3D printing for solutions. And a lot of customers has gaining and retaining customer orders because the lead times is faster than competitors. That is basically the major advantage, respond faster to customers. And this is the end of my presentation. And if there is any time for questions, or if not, we can talk afterwards in the networking if there are more questions. Thank you.
A liderança, ela é natural de quem vende, pois quem vende lidera e quem lidera vende, ok? E a partir daí, eu tenho uma coisa que eu cravei em 1994, que é: liderar é fazer as pessoas à sua volta evoluírem.
Sempre ele olhando para ele, se questionando o que eu posso fazer para melhorar, o que eu tenho que fazer para mudar, como eu tenho que fazer para as pessoas produzirem mais, se engajarem melhor.
Está fantástico o evento, muito bem organizado. Estamos muito bem acolhidos, eu falo por mim, inclusive os clientes que a gente trouxe aqui hoje, temos um feedback muito positivo, então já antecipo para todos que está fantástico e eu tenho certeza que a tendência é simplesmente melhorar.
Like a